Welcome back. Today, we're going to demystify a really key tool in software design, the System Sequence Diagram, or SSD for short. Have you ever wondered how a simple idea, like a user story, actually gets turned into a clear blueprint that developers can use? Well, that's exactly what an SSD does, and we're about to see just how it works. Let's dive in.
All right, so first things first, before we can even think about designing how a system works on the inside, we've got to get super clear on what it's supposed to do from the outside. I mean, think about it. Every time you use an app or a website, you're basically having a conversation. You ask for something, it gives you something back. So the big question is, how do you accurately map out that dialogue to make sure the thing you build is the thing people actually need? We start with this awesome concept of a black box. This is a really important first step. See, at this stage, we don't care at all about the complicated code or the databases or the servers inside. Nope. We only care about two things: what goes in from the user and what comes back out from the system. It's a fantastic way to keep things simple and focused. So, how do we actually write down the behavior of this black box? Well, that is where our star for today's show comes in: the System Sequence Diagram. An SSD is basically a visual script. It's a picture that shows the back and forth conversation between a user, who, by the way, we call an actor, and the system. It maps out step by step who says what and in what order for one specific task, like, say, buying something online. And why bother doing this? Well, the bottom line is that an SSD forces everyone to be crystal clear. It makes us look at everything from the user's point of view and identify every single action the system needs to support. This gives the entire team, analysts, developers, you name it, a shared map to follow before a single line of code ever gets written. Okay, now for the fun part. Let's actually learn how to read one of these things. And don't worry, the notation is super simple and clean, but it's also incredibly powerful. We're going to break it down piece by piece. First up, you've got the actor. You'll see this little stick figure, and that represents the person, or hey, it could even be another computer system, that kicks the whole thing off. They're the one with a goal, they're the one who starts the conversation. Then, on the other side of the conversation, you have the system itself. That box, with the dashed line going down from it, represents our entire black box. We call that line a lifeline. All the messy, complex stuff is hidden inside that box. We only care about that one single lifeline it shows to the world. Now, when the actor actually does something, like they click a button or scan an item, they're sending a message to the system. We show that with a solid arrow pointing to the system. This arrow is a system event. It's the actor asking the system to do something. And what happens when the system answers back? You got it. We use a dashed arrow, this time coming back from the system. This could be anything: the total price, a confirmation message, you name it. It's the system side of the conversation. Simple, right? Okay, theory is one thing, but it's way more fun to see it in action. So let's get our hands dirty. We're going to take a simple user story written in plain old English and turn it into a full-blown system sequence diagram right here, right now. So check this out. On the left, we've got our story, a pretty typical use case for a checkout system. It's just a numbered list of steps. And on the right, that's our blank canvas. We've got our cashier actor and our system black box. So let's start building this thing. All right, let's walk through it. The story says the cashier starts a new sale. So boom, we draw our first message, a solid arrow from the cashier to the system, and we'll call it make new sale. Next, the cashier keeps entering items over and over. For that, we draw an enter item message, but we put it inside this box called a loop frame. It's just a brilliant, clean way to show do this again and again. So what's next? After all the items are in, the cashier says they're finished. That becomes our end sale message. Now, the system has to reply with the total, right? So we draw our first dashed arrow coming back with that info. Finally, the cashier enters the payment. That's a make payment message going in, and the system replies with a change and a receipt. And just like that, we're done. Look at that. Every single key interaction from that boring block of text is now perfectly and clearly captured in this one simple picture. The entire conversation, from starting the sale all the way to getting the receipt, it's all mapped out. So we know how to build one, but let's really drive home why this matters. Why is this simple little diagram such a big deal in modern software development? Well, the example we just did was a pretty straightforward cash sale, but, the real world is often way more complicated. What happens when you have to handle something like a credit card sale, where you need to talk to outside banking and tax systems? And this right here is where the SSD is just brilliant. On the left is our simple cash sale. On the right, the same basic process, but with a credit card. See how we just add more of those lifelines for the external systems? The notation scales beautifully. It lets us visualize these much more complex interactions without making a confusing mess. This brings us to probably the most important rule of all. Notice the message isn't scan barcode, it's enter item. And that's on purpose. The system doesn't really care how the item was entered, if it was scanned, typed, or looked up. All it cares about is the user's intent, which was to enter an item. Focusing on the what, not the how, is what makes these diagrams so powerful for design. So, look, if you take just one thing away from this today, let it be this. The system sequence diagram is a translator. It's the bridge. It takes the sometimes fuzzy, ambiguous language of a user story and turns it into the precise, logical sequence of operations you need to actually start designing the software. It's an incredibly powerful tool for just thinking clearly about any interaction. It forces you to define what the user really wants to do before you get lost in the weeds of how you're going to build it. So I'll leave you with this. Think about a process you go through every day. What conversation will you map first?